module is prepare to develop AI solutions on Azure. And what does it say? And as an aspiring Azure AI engineer, you should understand core concepts and principles of AI development and the capabilities of Azure services and used in AI solution. What are the learning objectives of this module? That we will define what is artificial intelligence. We will understand what are the AI related terms, understand considerations for AI engineers, understand considerations for responsible AI, Azure machine learning capabilities of Azure AI services, capability of Azure bot service, and capabilities of Azure cognitive services. What are cognitive search? The services are provided by Azure. We're going to have a look on that because we know we require a cloud platform, learning of cloud platform. So this is a very great, interesting opportunity that we have provided by Azure that we can learn it totally free. So let's start with the first lecture. So what are the prerequisites for this? Before starting this module, we should have the familiarity with Azure and Azure portal and a basic understanding of software engineering. That you should have a basic knowledge and how it is working. These are the prerequisites of this course. If you have this knowledge, then we can move forward with that. If you don't have, then I'll share another video where you can, or if you just go to Google, then Azure also provided the machine learning basics. So we can do that certification first, and then you can come up and do this course. So this module is started of these learning paths is started with your AI services and prepare for AI engineering. So let's go with the introduction. So you want to become an AI engineer, right? Which everyone is talking about. So you start journey with an exploration of the core concepts and principles on which artificial intelligence is based, and an overview of Microsoft Azure services you can use to develop AI solutions. So we should have the we should explore the core concepts and principles of artificial intelligence and what it is based on, and overview of the Microsoft Azure services we can use to develop the AI solutions. So Azure is provided some already services which is providing, where we do not actually need to write the code for it. All the NLP tasks and the computer vision tasks can be done provided on the can be done on the cloud platform, which is requirement of the industries. With business, if you go in an interview, they ask for it. So, and if you're certified in it, then it's like an amazing thing that you can put it on your CV also. So after completing this module, you will be able to define what is artificial intelligence and understand AI related terms, consideration for AI engineers, consideration for responsible AI, Azure machine learning, Azure AI services, Azure bot service, and Azure cognitive search, as we have seen it in the last slide. So we have completed this module. We go to the unlock achievement. Alright, my bad for you. It must not be that. It would be showing you something different, because what we have to do is we have to go on the second chapter, that is define artificial intelligence. I have already done it, so it is showing me in a different way that you have already finished and it's certified. So how do you define artificial intelligence? Artificial intelligence is increasingly prevalent in the software application we use every day, including digital assistants in our homes and cell phones, automotive technology in the vehicles that take us to work, and smart productivity applications that help us do our jobs when we get there. I think this we know, right? What is artificial intelligence, and it's a boom in the industry, and software applications is being used every day, and including all our digital assistants in our homes, our cell phones, and all this automotive technology in the vehicle that is used by Tesla and all these companies, where it's this artificial intelligence where you are having a driverless cars on your road. So why actually is artificial intelligence? What actually is artificial intelligence? What it is? So there are many definitions, some technical, some philosophical, but in general terms, we tend to think of AI as software that exhibits the one or more human-like capabilities as shown in the following table. There are many definitions, but one which we stick to and one which we can define of is that exhibits one or more human-like capabilities as shown in the following table. If it is visual perception, the ability to use computer vision capabilities to accept, interpret, and process input from images, videos, tips, and live cameras. This is a great opportunity where if sorry, I mean this is the capability that AI is having. It has the ability to use computer vision capabilities to accept, interpret, and process input from images, videos, teams, and live cameras. Then it is able to analyze the text analysis, the ability to use NLP to not only read but also extract the semantic meaning from the text-based data. Okay, and then third is speech, the ability to recognize speech as input and synthesize or spoken output, and the combination of speech capabilities together with the ability of NLP of text enables a form of human computer interactions that become known as conversational AI, that is very famous right now these days. That if you have the ability to speak, the ability of speech, and when we combine it with the NLP analysis text NLP analysis, it enables it enables to in form of a human computer interaction that you can have a complete conversation with, and we call it conversational AI, in which users can interact with AI agents, usually referred to as bots, and in much the same way they would have another humans. So these agents is bots here right now, and it's different from the lang chain, and I'll be making one video on the lang chain also. I'll be because it's my plan that I will be learning lang chain for the agents, and then I will cover up that also, how amazing that technology is itself. And the fourth is decision making. So what is decision making? The ability to use past experience and learn correlation to assess situations and take appropriate actions. For example, recognizing anomalies in senior readings and taking automated actions to prevent failures or system damage. So if it has the ability to make decisions, that is the ability to use past experience and learn correlations to assess situations and take appropriate actions. It is able to take appropriate actions by analyzing the situations, by using the correlations. Like it is recognizing the anomalies in sensor readings and taking automated action to prevent failures or system damage. So if it has these four capabilities, then that is visual perception, text analysis, speech, and decision making, then normally we define it as an AI. So these kind of capabilities are increasing with the reach of everyday software applications, helping make them more intuitive and useful in a wide variety of scenarios that provide existed only in the realms of science fiction. It sounds like a science fiction, but now it's reality. So then we go to our next module, that is understand AI related terms. So there are several terms that people use when talking about artificial intelligence. So it's useful to have clear definition for each. Artificial intelligence, machine learning, data science. What is the difference here? So what is data science? So data science is a discipline that focuses on the processing and analyzing of data, applying statistical techniques to uncover and visualize relationships and patterns in the data, and defining experimental models that help explore those patterns. So that's what data science is, that you are processing and analyzing the data, and you're applying the statistical techniques to uncover the visual relationships and patterns in the data, and you're defining experimental models that help explore those patterns. You're trying to capture those patterns using the experimental models, and you create your own models so that you can have predictions. That's what data science is. So for an example, data science might gather some samples of data about the population of an endangered species in a geographical area and combine it with the data about the level of industrialization and economic demographics in the same area. The data can then be analyzed using statistical technique to extrapolate from the samples to understand trends and relationships between human activities and wildlife, and test hypotheses using models that show the likely impact of human activity on the wildlife population. By doing so, the data science may help determine optimal policies that balance the need for economic well-being for the human population and the need of conservation of the endangered wildlife. So this is an example. Hope you have understood. This is basic. I'll try to cover up the theory a little faster so that we can go more towards the practical application of instead of just theory. Then next comes the machine learning. So machine learning is a subset of data science that deals with the training and validation of predictive models. Typically, data science prepares the data and then uses it to train model based on algorithm that exploits the relationship between the features of the data to predict value for an unknown labels. If you see in a simple format, you have an Excel sheet, you have several columns. So your one column is the value which you want to predict. Suppose you want to see that who is going to win the match today, or who is going to win the World Cup. So you have all the statistics, and you have all the teams there, and you have all the values of different columns. It can have different attributes. So the run score, the strike rates, all these attributes are counted as features, and the prediction that if the country is going to win the World Cup or not is counted as your label. Then that is yes or no, and then in binary it comes as 1 or 0. And then by capturing all the statistical analysis of the data from the you capture the patterns, and then you make experimental models, and using those models you try to define the predictions. That's what comes under machine learning. Then comes as artificial intelligence. Artificial intelligence, what does it do? Artificial intelligence usually, but not always, builds on machine learning to create software that emulates one or more characteristics of human intelligence. It's usually built on machine learning to create software that that looks like characteristics of human intelligence. And so for example, balancing the need for wildlife conservation against economic development requires accurate monitoring of the population of the endangered species being protected. If you suppose you're trying to balance the wildlife conservation against an economic development, and you require to accurately monitor the endangered species and protect it, so it may be not be feasible to rely on human experts who can positively identify the animal in question, or to monitor a large over a sufficient period of time to get an accurate count. Indeed, the presence of human observers may deter animals and prevent their detection. In this case, a predictive model could be trained to analyze image data taken by the motion activated cameras in remote locations, then predict whether a photograph contains a sighting of the animal. The model could then be used in a software application that responds to automated identification of animals to track animal sightings across a large geographical area, identifying the areas with dense animals population that may be candidates for protected status. So what is this artificial intelligence? This is about is, if you see this, what the example, what it is giving, that you want to protect the wildlife from the economic development which is happening around, and then the endangered species you want to monitor. But if you can't rely on the human experts that you constantly monitoring them for that, that's what you do. You have motion sensor cameras which are capturing the live images of those animals which are passing by. You have fitted it on several places, and then the motion sensors cameras captures the images or the videos, the live streaming videos of the animal passing by. And on basis of that, you have to find a model where it identifies that if that animal is of that species, and then that's how you use artificial intelligence to actually keep the count of the number of animals which are actually there. So the model should then be used in a software application that responds to automated identification of animals to track animal sightings across a large geographical area, identifying areas with dense animals population may be candidates for protected status. So that's how you can use artificial intelligence, and that's all we know, all these applications. Let's quickly finish the theory, and so that we can move to the coding part, right? So okay, so this we have already done, my bad. We have understood the AI terms and considerations for AI engineers. So what you should consider: AI engineers. Increasingly, software solutions pro includes AI features. So software engineers need to know how to integrate AI capabilities into their application and service. They should know how to integrate the AI capabilities and the advance made in machine learning, together with the increased availability of large volumes of data and powerful compute on which to process it and train predictive models, has led to the availability of pre-packaged software services that encapsulate AI capabilities. Software engineers can take advantage of these services to create applications and agents that use underlining AI functionality, use them as building blocks to create intelligent solutions. You just need to enable you should capture the capabilities of AI, and then you should integrate it with your softwares so that you can use it. You should have that knowledge. This means that software engineers can apply their existing skills in programming, testing, working with source control systems, and packaging applications for deployment without having to become data science or machine learning experts. So the software engineers, they already have this programming, testing, working with source control system and packaging applications for deployment, but they can all use all these services without actually being an expert in data science or machine learning expert. They already have the programming knowledge, and they can use these skills to and Azure services to combine them, and then instead of just having a practical knowledge of the how the algorithms are working, but if you know what you're trying to do, you can always integrate into that. So how to fully capitalize on the opportunities of AI? Software engineers do require at least a conceptual understanding of core AI and machine learning principles, but it is always better to have an understanding of the basic principles, as we know. Then next comes this model training and inferencing. So many of AI systems rely on predictive models that must be trained using sample data. So the training process analyzes the data and determines relationship between the features in the data be present. The data values will generally be present in new observation, and the label the value that model is being trained to predict. After the model has been trained, you can submit the new data that includes feature values and have the model predict the most likely label. Okay, so let's start. So we have model training and inferencing, what we were doing. So many AI systems rely on the predictive models that must be trained using sample data. The training process analyzes the data and determines the relationship between the features in the data and the labels. So you have features and then you have label in your data, and then that's how the training is done. After the model has been trained, you can submit the new data that includes known feature values, and you have the model predict the most likely label using the model to make predictions. It is referred as inferencing. So you have trained your models on the same features. Now you have new data, you have all those same features, and then you want to make a prediction about some value. That suppose you're looking at who is going to win the World Cup. Let's take the same example. Then you have all the statistics and the values were there, and you prepared a model by using all those statistical techniques, and finally deciding which models you are going to use. And once you make a model, and then you have the new data, and for this World Cup, you have made your model on the previous on the old World Cup data, and for this World Cup, you want to know who is going to win. Then you feed all your data using those same features you have, and then you have to predicting it, who is going to win, and that is called as inferencing. This is what is called as inferencing. So many of the services and frameworks that software engineers can use to build AI-enabled solutions requires a development process that involves training a model from existing data before it can be used to inference new values in an application. Okay, so then comes this probability and confidence scores. So well-trained machine learning models can be accurate, but no predictive model is infallible. The prediction made by machine learning models are based on probabilities. That is very important thing. And while software engineers do not require a deep mathematical understanding for probability theory, it is important to understand the predictions reflect statistical likelihood, not absolute truth. These the values, the predictions which we are making, they are not absolute truth. These are the likelihood of the chances of happening by using statistical likelihood techniques which we are using. So in most cases, predictions have an associated confidence scores. So that's why they are introduced with a confidence score that reflects the probability on which the prediction is being made. So software development should make use of confidence score value to evaluate predictions and then apply appropriate threshold to optimize application reliability and mitigate the risk of prediction that may be based on marginal probabilities. So that's why when the software developers they should use this confidence scores to evaluate the predictions and apply appropriate thresholds to optimize the application reliability. That how that score, that prediction can be used for what range, the software developer should have that knowledge, and so that he can mitigate the risk of predictions that may be based on marginal probabilities, and that's that the error of prediction can be mitigated by by the software developer once he introduces the confidence intervals and have the understanding of that. So he has to define appropriate threshold to that value, that okay, for this value you can use this software for to this value. If it is more than that, then the predictions will go haywire and we can't use it. So then comes this responsible AI and ethics, and this is the very important part of artificial intelligence. It's important for software engineers to consider the impact of the software on users and society in general, including the ethical consideration about its use. When the application is imbued with artificial intelligence, these considerations are particularly important due to the nature of how AI system works and inform decisions, often based on probabilistic models, which are in turn dependent on the data which they were trained. So the human like natural, so what is happening here, what we are saying here, responsible AI. So the most important factor for software engineers to consider is when they are making these softwares, that the impact of software on users and society in general, that what is going to be the impact of the software on the user and society in general, including the ethical considerations. Is it the is the AI being toxic, or is it biased, or is it racist? Those are some of the major factors which needs to be considered. So when the application is imbued with artificial intelligence, these considerations are particularly important due to the nature of how AI system work. So these consideration, this is very important part that we need to consider it, because the way AI works, it says the most probabilistic value, and it gives the most probabilistic terms. The next word will be the most probabilistic term, the highest probability value. So it's capturing the meaning, but it is, since it has been trained on those kind of data where it was the data might itself might be biased, right? the not because it's been trained on the natural languages, the LLMs has been trained on natural languages. How do you actually control it? You have to make your AI responsible. So often based in probabilistic models which are in turn dependent on the data with which they were trained. Then human-like natural nature of AI solution is significant benefit in making application user-friendly, but it can also lead users to place a great deal of trust in the application's ability to make correct decisions. The potential for harm to individuals or group through incorrect predictions or misuse of AI capabilities is a major concern. The potential for harm to individuals or groups through incorrect predictions or misuse of AI capabilities is a major concern, and software engineers building AI solutions should apply due consideration to mitigate these risks, ensure fairness, reliability, and adequate protection from harm or discrimination. This is the most important role the software developers has to pay attention to. Okay, now let's understand the capabilities of Azure machine learning. So we have covered for now what we have covered. We have covered conversation for AI engineers, conversation for responsible AI. We did this. Oh no, we did not do this, right? We did consideration for AI engineers. Okay. So the next is we have to consider for considerations for responsible AI. So what is responsible AI? The previous unit introduced the need for considerations where we defined what are the requirements to have a responsible and ethical development of AI enabled software. So in this unit we will discuss some core principles for responsible AI that have been adopted at Microsoft. So the core principles of the AI that has been adopted at Microsoft are: first one is fairness. What is fairness? AI systems should treat all people fairly. It has to. It cannot define on basis of sex, male, female, on basis of race, African, American, Asians. It cannot define on basis of that. It has to be very fair. So suppose you create a machine learning model to support a loan approval for application, and if your model is biased and then it is not fair, and your AI is not fair, then it gives an unfair advantage to the people who it is biased towards. So that's what this example is about. Then comes as fairness of machine learning system is highly active area of ongoing research, and some software solution exist for evaluating, quantifying, and mitigate unfairness in machine learning models. However, tooling alone isn't sufficient. To ensure fairness, consider fairness for the beginning of the application development process, carefully reviewing training data to ensure it's representative of all potentially affected subjects, and evaluate prediction performance for subjects and so for subsections of your user population growth through the development cycle. So in just training the just tuning the data, tuning the model is not enough. Our tooling alone isn't sufficient. What it's saying is tooling alone is not sufficient to ensure fairness. You should have what you should have that your data should not be biased in itself. If your data is biased, then it doesn't matter what you do, it is going to give you a biased results. Then comes as reliability and safety. An AI system should perform reliable and safely. And for example, consider an AI-based software system for an autonomous vehicle or machine learning model that diagnoses the patient's symptoms and recommends prescriptions. Unreliability in these kind of systems can result in substantial risk to your human life. Can you imagine that you are having a machine learning model and then it is biased and it is not reliable, it is not safe, and then it gives you some predictions, because what it is saying is it is diagnosing the patient's symptoms and recommending prescriptions on basis of the symptoms. And if your model is not performing well, it is not reliable and it is not safe, then you can the risk here is human life itself. So you need to consider the reliability and safety of the models. So as with any software, AI based software application development must be subject to rigorous testing and deployment management process to ensure that they work as expected before release. Before releasing, it has to be rigorously tested and has to be tested by management before deployment to ensure that the work being done is done nicely, and there is no biasness or unsafe in any way. So that's from this side. And then additional software engineers need to take into account the probabilistic nature of machine learning models and apply appropriate thresholds when evaluating confidence scores. So prediction is very important part. We don't talk about it, but because as we see that when we are actually talking, we see that this is what actually practical is. We are talking GPT, and GPT sounds like an amazing artificial intelligence, but you can't rely on those, the way the why the reason it creates hallucinations and all that, because it comes out of the probabilistic nature. It has a confidence interval score that the value cannot be this right for a particular range, and if it is going out of that, then it gives you higher risks, and that has to be considered when developing your models. You have to apply appropriate threshold, and you have to evaluate the confidence scores of the predictions, that your predictions which you're making, what is the confidence score of that prediction. So, what is the privacy and security here? Then the AI system should be secure and respect privacy. The machine learning models on which AI systems are based rely on the large volumes of the data, which may contain personal details that must be kept in private. Even after models are introduced and the are trained and the system is in production, they use new data to make predictions or take actions that may be subject to privacy or security concerns. So, appropriate safeguards to protect the data and customer content must be implemented. This is very important, that the AI system should be secure and they should respect privacy. The machine learning models on which AI systems are based rely on large volumes of data which may contain personal details, and that must be kept private. You can't public them because they are personal details. So after models are trained and the systems is in production, you have already deployed it, and then they use new data to make predictions or take actions that may subject to privacy or security concerns. So appropriate safeguards to protect data and customer content must be implemented. You have to do the data integrity of the each and every customer of yours, and you have to take care of that. Then comes inclusiveness, that AI system should empower everyone and engage people. AI should benefit to all parts of society regardless of their physical ability, gender, sexual orientation, ethnicity, or other factors. It has to be an inclusive in nature. One way to optimize for inclusiveness is to ensure that the design, development, and testing of your application includes inputs from as diverse a group of people as possible. This is your one practical application. Then comes this transparency. So it has to be inclusiveness, then it has to be transparent. That AI system should be understandable. The user should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. That has to be shown to the users, and users should feel that how it is working. And for example, when an AI system is based on machine learning model, it should generally make users aware of factors that may affect the accuracy of its prediction, such as the number of cases used to train the model, the specific features that have the most influence over its predictions. You should also share information about the confidence scores for the predictions. That has to be also shared. The confidence scores for those predictions has also be shared. And when AI application relies on personal data such as facial recognition system that takes images of people to recognize them, you should make it clear to use how their data is used and written, and how and who has access to it. We have to make all these things clear. The models has to be transparent. The way we are collecting the data, that has to be transparent. You can't play with the data integrity part, and it has to be maintained at all costs. And then comes with the accountability. The people who should be accountable for AI systems. Although many AI systems need to operate autonomously, ultimately it's the responsibility of the developers who train and validate the models they use and define the logic that bases the decision on model predictions to ensure that overall system meets responsibility requirements. The overall responsibility of the person who has developed it and defined the logic that bases these decisions or model predictions which has been made, is the person who is coming behind and who has developed those model has to be accounted for. So to help meet this goal, designers and developers of AI based solutions should work within a framework of governance and organizational principles that ensure this solution meets ethical and legal standards that are clearly defined. So that's why for all the AI based solution, there has to be within the framework of a governance and organizational principles. There has to be defined. You have to define for your organization that the ethical way of defining the problem, the framework of the governance of these problems or the solutions which has been generated, and organizational principles, so that the solution meets the ethical and legal standards that are clearly defined. Okay, then comes in place. Next is machine learning. We have done which part for responsible AI we have done. So responsible AI was fairness, reliability and safety, privacy and security, inclusiveness, transparency and accountability. These are the major things which has comes under the AI. Then comes, let's see the capabilities of Azure machine learning. So Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for running experiments at scale to train predictive models from train and publish the trained models as services. So it's the machine Azure provides. It's a cloud-based platform. We all know, that for running experiment, it is providing you space cloud for running experiments at scale to train predictive models from data and publish the trained models as service. And you can train your model on the platform and then you can deploy it on the platform, and that's the best part about these cloud platforms. You don't need to go somewhere else, you can just deploy it right. So Azure Machine Learning provides the following features and capabilities. So feature, what is feature? Automated machine learning. This is the feature. This feature enables non-experts to quickly create an effective machine learning model from the data. So the Azure Machine Learning provides the following features and capabilities. The first feature is automated machine learning. The feature enables non-experts to quickly create an effective machine learning models from the data. The person who is not even familiar with machine learning that much can create their own models. Azure Machine Learning design a graphical interface enabling no-code development of machine learning solutions that has been provided. It has a graphical interface where you don't need to know the code, and then you can do the machine learning solution which you want to apply for. And then data and compute management, that cloud-based data storage and compute resources that professional data science can use to run data experiments code at scale. This is very important. This is what as Azure is providing us, and it's a very great help that you can your cloud-based storage and this compute resources that professional data science are using, you can use to run data experiments code at scale, at higher scales, without being worrying about the way you actually store your data. It's terabytes of your data. So then comes as pipelines. The data science software engineers and IT operation professionals can define pipelines to orchestrate model training, deployment, and management tasks. So you can create pipelines for your complete task, from where to extract the data and how you're uploading your model, and then you're creating APIs, and then you're deploying all these models which can be used by the users. And these pipelines has been used can be used as services by the person who is actually developing a model, or the organization who is developing the model. So these are the features that has been provided by the Azure Machine Learning, and data science can Azure Machine Learning throughout the entire machine learning life cycle to ingest and prepare data, run experiments to explore the data and train predictive models, deploy and manage trained models as web services. These are the what data science are doing and can do it on this platform. Okay, then software engineers may interact with Azure Machine Learning in the following ways. So these are the way how the data science were interacting, and how software engineers will interact. They use automated machine learning, Azure Machine Learning Designer, to train machine learning models and deploy them using REST services that can be integrated to any AI-enabled applications. And then collaborating with data science to deploy models on common frameworks like scikit-learn, PyTorch, and TensorFlow as web services, and consume them in applications. And then using Azure Machine Learning SDKs or commands line interface to scripts to orchestrate the DevOps process that manage versioning, deployment, and testing of machine learning. So these are the way which the software engineers can use this platform and these AI capabilities of the provided by Azure. Okay, so the next is we have done this understanding capabilities of Azure AI and how those data science can use Azure machine learning, and how software engineers can use Azure machine learning. And then let's go to Azure AI services. So Azure AI services are cloud-based services that encapsulate AI capabilities. We know you should think of Azure AI services as a set of individual services that you can use as building blocks to compose sophisticated intelligent applications, which we can use them. And Azure AI services offer a wide range of pre-built AI capabilities across multiple categories, with examples showing in the following table. So these Azure AI services can be used for different categories: for text analysis, for question answering, for language understanding, translation, name entity recognition, and custom text classification, speech and speech transition. These are the various techniques where it can be. These Azure AI services can be used. Okay, you can go through it. There's not much to cover in this. And then let's go to Azure Bot Services. The capabilities of Azure Bot Services, what it is able to do. So bots are AI powered software agents and that can be engaged in conversational interactions. For example, a website may include a chatbot interface in which user can submit questions in natural language and receive conversational responses, or an organization might use a bot to answer incoming phone calls and gather initial information before forwarding the call to appropriate operator. So these bots we know, and these are very common now these days. It's been not common, but it's a high boom that you can define your own bots for your services, and it can actually talk in a natural language, and receive and conversational responses. Or an organization might use a bot to answer incoming phone calls and gather initial information before forwarding the call to the appropriate operator. So the Azure Bot Service is an applied AI services for developing and delivering bot solutions that support conversational interactions across multiple channels such as web chat, email, Microsoft Teams, etc. and other services. And AI engineers can develop bots by writing code using the classes available in the bot framework SDK, or alternatively, you can use a bot framework composer to develop using complex bots, use a visual design interface. If you understand this, there's not much. And then capabilities of Azure cognitive search. So searching for information is the most common requirement in many applications, from dedicated search engine websites to mobile apps that can find context appropriate information based on where you are and what you want to accomplish. Okay, so Azure is what it is doing. So actually this gets a little boring because we are not typing the code, and that's why I'm trying to finish this theory a little faster. And once the code comes, and then when you can type and make your hands dirty, I think we will feel more of what it is we are doing. But yeah, we should have the knowledge of the platform first, right? So Azure Cognitive Search is applied AI service that enables you to ingest and index data from various sources and search the index to find, filter, and sort information extracted from the source data. In addition to the basic text-based indexing, Azure Cognitive Search enables you to define an enrichment pipeline that uses AI skills to enhance the index with insights derived from the source data. For example, by using computer vision and natural language processing capabilities to generate description of images, extract text from scanned documents, and determining key phrases in large documents that encapsulate their key points. And not only this, an AI enrichment produces a more useful search experience. These insights extracted by your enrichment pipeline can be persisted in a knowledge store for further analysis or integration into data pipeline for business intelligence solution. So Azure Cognitive Services is an AI service that enable us to ingest and index data from various sources, we know that from various ways, and search the index to find, filter, and sort information extracted from the source data. And then in addition to basic text-based indexing, Azure Cognitive Services also enables us to define an enrichment pipeline that uses AI skills to enhance index with insights derived from the source data. For example, when you are using a computer vision and natural language processing capabilities to generate description of images, extract text from scanned documents, determine key phrases in large document that encapsulates their key points. You can define your pipelines with Azure AI and Azure Cognitive Researches, Azure Cognitive Services. Then comes is our knowledge check. So which is prediction made by machine learning model, absolute correct value and probable chance of selection, and probabilistic value based on data, so found on training data. So what it is, it is probabilistic values based on correlations found in the training data for the predictions which you are making by the machine learning models. So a data scientist has used Azure machine learning to train a machine learning model. How can you use the model in your application? We can use Azure machine learning to publish the model as web service, export the model as an Azure AI service. You must build your application using the Azure machine learning designer. Then we deploy them as web service. Azure machine learning can be used to publish the model as a web service, as a web application. And you want to index a collection of text documents and search them for mobile application. Which service should you use to create the index? Azure AI service, Azure cognitive search, or Azure bot service? We want to index a collection of text documents and search them for our own mobile application. So what it is it Azure AI or Azure bot? Azure AI services includes all the services, and we want to search them for mobile applications which serve them to use create the index. Let's go with this bot. let's see that one. It's cognitive search. Azure cognitive search. Anyways, so we know now what is the answer, and let's get back to. So this is what we have done, and this what we have summarized, and if we have understanding of all these terms which we have promised in the first lecture, the first session. Thus we finish the first module, and then in the next video we will go with the second module. So we have finished with this one for now, and then the next one will be creating and consuming Azure AI service. We will create an Azure AI service using REST API and SDK, and we'll go with that. That's it for this video, guys.